Three, two, one. Welcome to the SaaS Pulse Show. My name is Michael Bertoni, and I'm the founder and CEO of SaaS Talent. And really excited today. We are on the cutting edge. All this AI talk you hear out there, right? So we've got cutting edge here, AI, computer vision. Chris Andrews, he is the COO and head of product for Rendered.AI, one of the coolest companies. Like, I'm looking at your demos, unlimited synthetic data for computer vision. So it's great to have you on the show, Chris. Thanks for being here.
Yeah, thanks a ton, Mike. I'm super happy to be able to chat with you. So thanks for the opportunity.
Yeah, I got to tell you, I mean, you probably win the coolest product. Like, there's like, you go and there's like, pictures of computer vision being taken on your demo, and it's like apples becoming balls. And I mean, you're going to tell me more about it because I know you're the expert. But let's get into it here. What I always like to start with, Chris, is the superhero backstory, right? So basically, how you came to Rendered.AI, right? Share your background. Just share your background with the audience. Chris is also, for everybody listening to this, I told him, and I'm not patting him on the back, but I'm saying he's kind of a unicorn. He is a COO and a head of product, which pretty awesome. So if you're a startup listening to this right now, if you're a solopreneur, definitely reach out to Chris. I mean, he could help you. Those are two roles in the company that a lot of startups don't start with. They don't have their COO, they don't have their head of product. But yeah, so tell the audience a little bit, Chris, about your backstory. How did you get to Rendered.AI?
Sure. And it's I think it's directly applicable to your claim that I'm a unicorn, and really interesting to consider that because actually, from my perspective, I'd say that arriving into the role was actually a pretty natural fit given my background in software development, consulting, sciences, and then a lot of product management. And so we can come to that. So yeah, I started out as a with training in the sciences, actually in geology and biology. I was a programmer since I was a kid though, and when I got out of school in the late 90s, it was much easier to get a job as a software developer, and then it was in ecology, which is what my master's was in.
Right.
Plus, I had done a bunch of programming for my master's and invented my own basically geospatial software, and that those things together really are what landed me in my first roles. The very first couple of roles I was at were at small startups that went bust, and that's a common thing, right? So most
Mhm.
startups don't make it out. Like Rendered's been around for 5 years. That's a major milestone to pass. Many startups don't make it 18 months. Far fewer make it 5 years. We passed 5 years in May, so that's a good milestone to have passed through. After starting out in those smaller companies, I ended up with about a 7 or 8 year stint doing project-based consulting services. So I was a lead consultant, would go in with a company that was kind of a tier underneath some of the McKinseys and Accentures and those kind of folks.
Mhm.
And so we would go in and basically build out products for other companies, which is
Yeah.
largely what I did, often focused around geospatial software, but not only that. At some point, I got kind of tired of being at the end of the whip and always having to sell or implement something that somebody else was making decisions about. I decided to kind of retool my career by starting to write articles for back then print magazines and some online magazines
Nice.
about kind of bringing together different types of technology to solve problems. And one of those articles actually got me noticed by Autodesk.
Mm.
That is where I got into product management. I first joined Autodesk in a business development role, a technical business development role, and then I literally was hijacked as a product manager, which is what I'd been targeting all along. So 15 years later, after about splitting that time between Autodesk and Esri, I progressed through like solo, individual contributor product management, led product teams, and then when I left Esri, I actually managed a quarter of their product management division. I had a large group of PMs underneath me, a
Mhm.
lot of products, a lot of different product models, and everything from data to SaaS products to desktop products, free products, all kinds of different stuff. So I've seen quite a diversity. Along the lines there, though, I always managed to participate in innovation projects, new things in new industries. And I'd say that's one of the things that really stands out for me about my career is from the very beginning is I almost always was leading some type of product development or product management that was kind of 0 to 1 product in a 0 to 1 market. So a new product in a new market. And that's really what Rendered has been.
Yeah.
We, the combination of my background in 3D simulation, geospatial, product management really just led me into a couple of conversations about small companies who needed folks like me. And then I got introduced to Nathan Kuntz, the founder of Rendered, and he was looking for somebody to basically back him up as the other side of some of the tech inventor and experienced company founder that he was. He wanted somebody to help him set up the company and then start establishing a repeatable product play, and so I kind of just showed up at the right time.
Nice. That's an awesome story. I mean, for everybody listening to this, how Chris took control of his career. He's like, yeah, I don't want to be a developer anymore. I mean, so this we just starts writing articles. I mean, today you'd probably write blogs or you get some type of, posts or something. You're going to get noticed. If you're writing good stuff, you're going to get
Yes,
noticed. I mean, you could just do it on LinkedIn, right?
that's
So that, hats off to you. But in terms of the product, again, rendered AI, unlimited synthetic data for computer vision. That just sounds cool. Like that just sounds cool, right? So tell the audience a little bit about the product. What is the product? What's the value proposition?
so the company idea actually came out of the idea for Rendered specifically came out of some efforts by Nathan at another company he'd founded called Chimera, where he and his company were building complicated satellite communications hardware.
Mm,
They needed to test some of the communication algorithms that they were working on, and a huge problem was that they didn't have data because they needed their hardware to be deployed in space.
right.
And so it occurred to him that, well, what if you could simulate the data and actually use that to start testing out your algorithms? At the same time, I was working in the 3D geospatial field, and a lot of 3D geospatial is focused on things like scenario planning and operational training and different aspects of basically simulating real events and scenarios, both for humans and for machines to interpret. So when Nathan got the company started, he landed some pre-seed funding and then eventually closed seed funding right when I joined him. And the premise became that there's this issue of so right around the time that I was working in 3D heavily and Nathan was working on Chimera, we also saw the rise of AI, right? The
Yep.
whole AI market that we're seeing now, and which has then spawned uh, the generative AI market and
Mhm.
LLMs and all this other fantastic stuff that didn't even exist 2 years ago.
Right.
Um, One of the fundamental premises of AI is that you need a lot of data to train algorithms to be effective at what you need them for. So, and different businesses need algorithms to be effective in different ways and at different rates. Nathan saw a split, a kind of bifurcation in the market between kind of the text-based world and the computer vision world.
Mhm.
In the text-based world, in some ways, what you can say is that obtaining data sets to train can still be difficult, but
Mhm.
simulating them can be a little bit easier than simulating computer vision data, right? So
Right.
computer vision data is imagery or video or in some cases even 3D data that's collected, like LiDAR or other things like that. Simulating that stuff tends to be complicated, and it's not, if you can build a product to help people create computer vision content, then you have a moat. You have something that's hard for somebody else to do. And so there are that was the path that Nathan and the other couple founders chose, and they proved it out by selling a couple of projects and demonstrating that they could actually successfully help customers create simulated computer vision imagery. So that, and they chose a path of physically accurate computer vision imagery. So we attempt to help customers model the correct distribution of values in the pixels that are created in an
Sure.
image to actually emulate what the customer would be collecting in the field. And that can be from a drone or a satellite or a camera in an assembly line, for example. So through the first few projects that Rendered did, the team was able to prove that it was possible.
Mhm.
And then the team arrived at this realization that that they could go one of basically three different paths. They could continue doing project-based work for forever, and project-based work is there's a lot of it out there, but it's not really scalable. You have to
Right.
basically big professional services team. Another path that the team could have dived into would be to chase one of the big verticals. And the the biggest vertical that actually has been using synthetic computer vision data for quite a few years now is actually the autonomy vertical. If you go do a little bit of web searching, I'm not sure if we can call it Googling anymore because now so many people are using ChatGPT and Gemini and other things like that. But if you do a little bit of web searching, you will find that Tesla and Google and Amazon, Baidu, a lot of the large companies that were involved in both search and autonomy actually had built out synthetic data pipelines their own starting years ago. And
Hmm.
so some startups in the synthetic data space decided to chase those avenues. And then there's a third path, which seems to have been a bit more unique, which is what if you could just service a larger part of the middle and long tail who need access to simulated computer vision imagery, but don't have the wherewithal to build out their own full stack of hardware and cloud capability and simulation content, and then workflow, and then finally data generation. And so Nathan and the team had started a strategy to build a platform as a service for helping customers generate synthetic computer vision imagery to overcome the challenges of acquiring real imagery. And then I joined right around the time that they were kind of finalizing that strategy and helped them push the first version out the door.
I don't know if everybody listening to this is, I feel like I'm getting smarter as I'm listening to Chris right now. I mean, like as I mean, seriously, like as he's talking, I'm feeling like I'm getting smarter, like as I'm listening. So Chris, I mean, I'm not just blowing smoke, man. I could tell you're so smart. But you're talking about so many things too, like synthetic data pipelines. I mean, I'm so curious right now. So for the audience out there, what is a synthetic data pipeline? Like, what is that? Like, what and why? And so you're also mentioning about autonomy and, I guess that's, self-driving cars and things like that. But what's a synthetic data pipeline? What's autonomy? Like in autonomy, like how are they using that? Like that sort of thing.
Yeah, so let's maybe dial it back a little bit. So in machine learning is all about taking large data sets, training statistical algorithms to be able to build up kind of um, like a matrix of potential outcomes, and then passing other data instances that weren't in your training set through that matrix, and then having the data set categorized or classified in different ways. And there are different kinds of detectors that are built for when you're training a machine learning algorithm.
Mhm.
But that simple kind of visual is how I kind of think about it. You've taken a data set, you've kind of built a specific type of sieve that is based upon the uh, the distribution of values in that data set. And then when you pass other things through it, you end up uh, figuring out which specific holes in that sieve that the data instances pass through. There are really two types of data that generally that machine learning is applied to: text and so what's sometimes called structured data, although that even gets complicated. But if you think about like web forms, you entered your name, your address, your phone number, some complaints about some service and something else, and that data is already kind of pre-sorted in a way, right? You know which is the name, you know which is the address. When you start looking at sensor imagery, like camera imagery, or like you hear about LiDAR sensors these days, or think about a satellite sensor of some kind, that most of those sensors end up outputting images of one kind or another. So it boils down to pixels and pixel values. Pixel values, think about a typical bitmap that you might edit with Microsoft Paint. A typical bitmap will have four values: are red, green, blue, and maybe an alpha channel for transparency. There's no other information inherently in those red, green, blue, and transparency values, right? You don't know
Right.
that the green is because it's a grass green. It might be an eye color, an eye iris green, or it might be your shirt green, or
Mhm.
some other kind of green. There's no other semantic information in that pixel value. So the science of computer vision is all about taking data sets with known information in them and
Mhm.
figuring out how to build algorithms to then interpret unknown data sets such that you can reliably say this is an image of an elephant standing in grass with a blue sky and sun behind it, right? Because otherwise you have no idea what's in those images, in those pixel values. Synthetic data in general is simulated data intended to emulate some properties of real data sets. So in the text world, for example, you might be trying to simulate real data sets with legal records to anonymize out all of the plaintiff and defendant names and personal information, so that you could then apply some statistical reasoning to analyzing the data and not have any personally identifiable information slip out into the analyses. That's a privacy kind of filtering and emulating data sets for privacy reasons is a huge use of synthetic data in the text-based data world. For the computer vision world, that's still an important usage, and so we have some interest from, for example, the medical community, because we can do things like simulate humans, and you can simulate images of fake people to your heart's content and not be worried about violating anybody's privacy.
Right.
Um, However, there are other drivers in the computer vision space as well. Some types of data are just very expensive to get. If
Right.
it's a rare satellite image type, and it's $1,000 or $10,000 or more per image, then if you need 10,000 images to train an algorithm, well, that starts to get really expensive. There's another case where, back to Nathan's original problem set, if I am going to spend a couple $100 million or convince other people to spend a couple $100 million of their dollars to put a new type of satellite up into the sky because I'm going to be able to detect people smoking outside restaurants or something like that, something silly. Or say, methane plumes is what one of our customers' Planet was trying to prove that they could detect with their new satellite that's just about to be launched. They had an issue, which is that they wanted to train algorithms to be able to detect those methane plumes before they even started collecting
Right.
from their new satellite. And so they were able to actually work with us to generate imagery with simulated methane plumes that are in what's called hyperspectral imagery. So instead of four channels, four different values in those images, they have 450 or more values in each pixel location in those images. And so they were able to actually work with us to generate synthetic imagery on our platform, actually integrated into their AI training and tasking pipeline, and demonstrate that they would have a viable set of detectors once they were able to start collecting imagery. So that brings up the pipeline piece, but I want to pause there to see if you have any other questions.
Yeah, no, I'm like, again, I'm learning. I mean, so yeah, I could tell you're an expert. I mean, I'm learning here about computer vision in general. What I think everybody should understand who's listening to this right now is that if you're doing anything in computer vision, if you're thinking about doing anything in computer vision, you need to talk to an expert, right? So, reach out to Chris or reach out to somebody who is a true expert in the space, right? So, what I'm curious about more is the use cases, right? So, you're saying a lot of federal government, right? So, your ICP, people building satellites, people like, selling things into the federal government. I mean, I know probably you can't talk about some of this stuff,
Yeah.
but what's been that like the market? Like describe to me is your a lot of your market in the federal government and different, the federal government in itself is like its own beast, right? So explain to the audience what's the market look like?
So it's really interesting, and it's anybody who's thinking about SaaS or PaaS and that you've talked to, for example, in your last few months of starting the series, I'm sure that just about everybody has commented on how much the market has changed in the last couple of years.
Yeah.
So what we actually saw when I joined was kind of the tail end of some of that. I would say the growth marketing phase of the market in general,
Mhm.
which was that you could message, you could talk about what you were doing, and people still had some funds to start to
Yeah.
experiment with things. And so we actually did quite a bit of commercial business, and that was in all kinds of areas uh, from identifying scratches on train parts to we did a project for a large healthcare goods provider on generating images of people with different skin conditions. Uh, there were projects in agriculture and in a variety of other markets. The core set of customers, even in the commercial space that we had, though, even then, were in this kind of new space segment with a lot of folks who were either looking at developing imagery to prove that they could do something in the future, or who are looking for more imagery of a certain type to prove that they could do something with it now. So that means finding rare and unusual objects in imagery that would be interesting to the military, for example. A lot of that work is actually done by commercial companies who are service providers to the government. And interestingly, when you're generating synthetic or simulated content, most of that content is not secure, right? So
Right.
it's not secret, because you may be looking for very common things, but it's actually the patterns of occurrence of some of those things that actually tend to be more classified, and we don't get involved there. Like, the whole purpose of our platform is to allow our customers to be able to easily generate that imagery without our involvement. So for a lot of those customers, they once we help them get set up, we have a services enabled product today. So we often are involved in setting up the platform for the customer. But then once we get them set up with their own synthetic data channels, they're able to configure them, mix and match some of we call them nodes in these channels,
Hmm.
and then kick off jobs to their heart's content. And
Nice.
we don't even sell per pixel or per image. We sell just based upon compute capacity. And that's what
Hmm.
we mean by unlimited synthetic data generation. If you want to burn every minute of compute capacity available to you at your subscription tier, then go for it. it's unlimited except for the practicality that, we don't have infinite compute to allow you to burn through. So you purchase at different compute tiers. But so the market for a while looked heavily commercial. As we saw things starting to get a bit pinched because the economy changed a bit, we at that time though, the computer vision started to become a lot more important to the government, and we pivoted and we started doing a bit more kind of foundational government business. So there's a lot of research into how to improve computer vision for more sustainable operations in the government, and that's where having a platform as a service is really beneficial, because our platform has APIs and SDK. We can actually be integrated right into other pipelines that can task synthetic data generation. So you can actually configure it someplace else, task our platform, and then extract the data that you want and pull it into the other parts of your AI pipeline.
Yeah.
And so large companies, the Googles and Amazons and Teslas, and also large government organizations have these big enterprise pipelines for different types of data processing. And AI is definitely becoming one very common data processing pipeline type in those large companies. And Rendered plugs right in. We're even just in the final stages of finishing our first private cloud deployable version of Rendered, so that you don't have to operate it in our public cloud. You can purchase it from us and then run it. So it's been an evolution. Not sure if I completely answered your question.
No,
but,
you answered it. I mean, this, I got to tell you, I'm saying I'm learning, right? And this has been a great show. We actually gotta wrap it up. So Chris Andrews is, again, the COO and head of product for Rendered.AI. If you're doing anything at all in computer vision, everybody, either commercial or federally, if you know anybody, I mean, these are topics that they're on the cutting edge of. I could just tell they're on the cutting edge of. So definitely reach out to him. Chris, it was great having you on the show. Let's debrief for a couple minutes here. I'm looking forward to following up.
All right. Thank you, Michael.